Okay, so first thing I've come to start dismantling this and checking that everything's working properly is I've isolated the supply into here, which is now dead. I noticed that the pump is still pumping even though the power supply is off to the unit. So what's happening is, as the wiring has been done incorrectly on the zone valve over there, that's bringing a live supply permanently back into this because it's permanently open, and then these two connections are obviously attached onto the same section of the circuit board, so the pump and then the valve connections must be the same, you know, the same supply. One relay gets activated there, and that that activates both of these connections. So that supply is coming back in from the motorized valve as it's permanently on, and then it's putting a live onto the pump. So yeah, normally what we'd do is we'd have one supply that isolates, you have one supply that isolates all of it. So you've got like the boiler control, you switch one FCU off and it isolates the boiler, all the motorized valves, the UH8 and anything connected to it. So at least we know we switched that off and then it's all dead. In this case, you've got supplies coming in from different places, and then you've got the risk of, if you don't check properly, you're getting a shock because you think you've isolated it. So this is obviously why you have to do the safe isolation procedures and all that stuff. But yeah, that's the first thing I've noticed straight away is we have power onto a board that is isolated, which is pumping a pump, a valve that's open permanently, the boiler's fired up because it's trying to heat the hot water cylinder, and it's sending hot water down this pipe to here, and then this is attempting to pump it around a system, but all these actuators are closed due to this being off. So just a system like overworking or just working unnecessarily, basically, just because it hasn't been wired up right. Right, so I've just come back to this wiring now. So this flex here, this one that's had the earth cut out, that goes back to the UH8 and is connected into the zone valve connection in there. So that comes back here, and that is supposed to be activating this zone valve. Yeah. So this cable alone should just be wired onto this flex, basically, because that'll open and close it because the UH8 is doing all the work. So I think there's been a mix-up of UH8 and also your traditional, wiring for this type of system. Whereas normally you take the power in to this, and then a switch supply out, which is the orange, would then fire the boiler up. So what's happened is, so you see we've got the so this is the one from the underfloor heating motorized valve below. Yeah, that's for that one. So you got the earth and the earth, the neutral and the neutrals. So the brown normally would switch or open the motorized valve, and then the grey would be the common. So your switch supply would normally come from your time clock, and that would then say, right, or whichever programmer controller. So that would then send voltage to this, which would then open it, and then you need power supply onto the grey, which is your common, and then once this opens with the signal from wherever, this then puts power down call it the L1 connection, if you like, say a traditional light switch. So you've got common and L1. So this has a supply on it, this has a switch supply to it to control it, and then voltage is put onto this orange. So what they've wired here, as you can see, you've got the motorized valve there, goes into a connection which is that's permanently live. This cable here, so it goes onto a permanent live connection, which is also linked into the switch live connection, which is supposed to fire the boiler up. So basically this orange and this brown are in the same connection. So that's got a permanent supply down it. So it would seem that the boiler has got a permanent switch connection, a permanent live to it, which is telling the boiler to be on constantly. And the only thing that's switching the boiler off is the heat temperature sensors inside it. When it gets up to a certain temperature, it shuts the boiler off, and then it will let it back on again once it cools down, and it'll circulate inside here. It's got a circulation pump. It'll circulate the hot water. Once it detects the pipework is at a certain temperature inside the boiler, it'll switch the combustion off inside the boiler, and it'll allow that water to circulate while it cools down. It'll detect the temperature drop, then it'll fire the boiler back up. So this has got safety cutouts and stuff inside it that it would, you don't want to rely on that, but it's there for a reason, for safety. So what's happening here is that it's basically all just been stuffed into one joint, permanent live. So that's why we're getting a permanent live over there. That's why that pump's circulating, that's why this is permanently open, and that's why this boiler is permanently calling for heat. Because it's just the switched connection to the boiler is wired into a permanent live supply along with the motorised valve. So after a couple of hours now faffing around with this, trying to see if we can make this system work efficiently with what he's already got, he's going to get a plumber to come back and redo all this pipe work anyway. So we've just decided to rip it all out and just start again. It's just easier, because forget this system, what I've come to do. This system isn't even working properly. It's just the boiler's been on permanently and switching on, off, and circulating heat with absolutely no control over it. And these valves have just been open in open positions, and it's been getting heat through to places that don't need heat, basically. And yeah, this has just been permanently going. So that's not running efficiently anyway. So we need to get this stuff working all together. We need to get it all working properly. So yeah, I'm just going to rip it all out and start again. So here's the other issue. I did mention it before. About a safety temperature sensor connections on the cylinder. I couldn't see any. So this is a mega flow unit. Sometimes they've got let's say a hole in the side of it, and then you put a probe in there, and then that is connected and reads the temperature of inside the cylinder. So to be able to cut the boiler off when it's reached temperature, again, is a safety issue, a safety thing. So on this hasn't got any of the connections done. So we've got the immersion coming in into the immersion connections, and then these are the connections here. So we've got element control, which is the temperature of the that you'll allow the water to get to using the immersion heater. So say we want it at 60, 50. That's how we adjust that. Once it reaches temperature, it will shut off. The power coming in here is a permanent supply. Once this reaches, it goes through this and then to the immersion element. Once this reaches temperature, it cuts. It is a switch, and it cuts the power supply going to the element, and it'll keep doing that on off, on off, on off. Once it drops below 50, that will then switch back on and then allow current to flow through the immersion heater. So that's how that works. This is a safety cutout switch for the temperature inside the cylinder while using the immersion heater. This is, as you see there, boiler control. So this is the temperature that we can set or allow the water to get to using the boiler to heat the cylinder. And then there's some connections here which are for isolating the boiler control once it's reached temperature. So, like I say, I noticed before that I couldn't see any other cables coming out of the cylinder. This is a safety thing, which is vital. Stops the water boiling inside the cylinder, stops water pressure building up inside this, so it doesn't start blowing joints off this. Because once this cylinder gets past a certain temperature, it can only deal with a certain pressure, and then all these joints are going to start, well, they're already failing anyway, but you know, we're going to get in ones, these have got a certain pressure rating on them, each connection, and potential for this, you know, you could get an exploding, an extreme case, you could get a cylinder that explodes if the pressure builds up enough in it for it to burst. That's a possibility. So this is why we have these safety cutout switches on here, temperature sensor switches, so to make sure that we don't get too much pressure build-up inside the cylinder. So at the minute, there's none of that. There's none of that. Yeah, so there's no connections into here. There is no link between this and the boiler. These cables here, there's nothing that goes between here and here. So that is extremely dangerous. So we're ripping out anyway, so I'll put another cable in, but again, that's just something else that this guy's missed. Now, I just experienced a phone call with the customer and the plumber, because he's rang him up and said, look, this is leaking, that's leaking, and he says, the guy's here to do the heating. He said, oh, what? Do what heating? He says, I've done it. So he'd connected this up, and apparently he's paired the thermostats to this and chucked them in a box so this works, basically. So all these relays are open, and then it allows them to be open, and that was manually on, so it was heating up. But this is his version of I've done it. Everything I've just explained before, live coming into here from somewhere else because the zone valve isn't wired correctly, boilers permanently running, no safety cutout switches on in the cylinder. So this is his version of I've done it, which is shocking. So yeah, so that's what we're going to have to do with this then. Yeah, we're going to have to put a 2-core cable into there, and then to this joint box I'm going to mount this Nest controller just on the wall there, with a joint box with all the cables going to the boiler, cables going to the UH8, cables going down to the cylinder, and all the cables from these going also into, so one joint box, everything goes into that. And then I'm going to mount the controller for the hot water and the radiators upstairs there, local to where all the connections are, makes it a little bit easier. And then I'm just going to use one FCU supply, so that one there I'm going to disconnect. I have disconnected, sorry. Lose that. I'm going to take one cable from here, one 5-core cable, up and over to that joint box, and then I'm going to supply everything from that FCU next to the boiler. So when you want to come in here and work on this entire system, you turn that isolator off. That isolates everything. Power to the boiler, power to the valves, control of the cylinder, UH8, all the actuators, pumps, everything. One FCU, 1 point, controls all that. So it's a lot easier, safer to work on, and a lot less. It's just so convoluted the way this has been done. This is a connection to safety connections that I was telling you about. So I'm just going to show you now, as I haven't got any instruction manuals for this, and I've had a look on the PDF for it, and the actual connections, on the drawings there, sorry, should I say, on the PDF download for Megaflow. It showed me two lots of connections. It showed me like direct and indirect connections, but it didn't, and it just says 1, 2, 3 on the connections. It doesn't kind of tell you cooling, common, cooling, heating on the instructions. So I'm just going to show you now how you can identify the connections on these without the instruction manuals, for if you're going to be doing the same thing and including, you need to add a safety temperature cutout connection onto a system like this. So we've got connections 1, 2, 3. It's written on the top of these connector blocks here. So right, so what we're going to do is we're going to use a meter like this. So we want a continuity tester. This gives you a little beep indicator. it just lets you know that whether it's open and closed circuit, so it's something simple like that. So we're going to turn the temperature down to the coolest temperature. So let's see. Right. So I'm getting continuity between 1 and 3 and not between 1 and 2. So when the temperature is down, we want it to be off. So if we had the connections 1 and 3 linked out with a cable, turn the temperature down, that would be actually calling for heat, because there's it's switched between 1 and 3. There's continuity. Yeah. So if we turn this back up, just confirm. There's a little click. So that's now calling for heat, and it actually has opened the switch connection. So that's not the one we want. We want now it to be calling for heat. So now the connection is on to the continuities between 1 and 2. Just double check it, because sometimes these switches can be faulty as well. So you need to make sure that the switch is switching correctly before you start using it anyway. So always double check that the thermostat is functioning correctly. Right, so I've turned it down, which is now it should be calling. Sorry, turn it down now, it shouldn't be calling, so it should be off. Yeah, turn it back up. Now we're calling for heat, so that's the one we want. Yeah, so that's basically, I would simplify it by saying cooling. When it gets cooler, it switches the switch on, and then this one is for heating. And when we turn the temperature up, we get continuity. So we could use that switch for cooling, so when it drops below a certain temperature, a fan kicks in, an air conditioning unit or something like that, you know, could be used with one of these types of switches. So cooling connection between 1 and 3, and then heating connection between 1 and 2. So that's how you're going to confirm that you've got the right connection. So just to say again, we want this calling for heat, that's up to say 60-70 degrees. This temperature of the cylinder is at 50, so we want that to heat this cylinder up to 70 degrees. So we want this to be switched on. We want the continuous connections, and 1 and 2 is continuous, 1 and 3 is not. So we know that we need to put our switch connections between 1 and 2. Once this is wired into here, we're going to wire that back up to the joint box up there, and it's going to be a break in the cable basically from any time clock controller. It's going to go through this, so the time clock will come on, a live switch will come out of the time clock, then it's going to be wired down one core of the cable that's going to come to here, and then the other core of the cable is going to go back out and then to the boiler connection basically. So if the cylinder is satisfied the temperature, that means it will the connection will be open, and then it won't allow the boiler to fire up. So just because the hot water controller is on and calling for heat doesn't necessarily mean that this is actually heating up. Yeah, because this switch here won't allow it. This switch here won't allow the motorized valve to open, and it won't allow the boiler to fire up in this situation when we're calling for hot water. So that this everything has to go through this switch first as a safety precaution. This is everything ripped out now. No cables dangling everywhere anymore. no connector blocks. Just removed all this, start again. It's already looking better.